70-740 Lesson 6, Creating, Managing, and Maintaining Images for Deployment. This is a very important lesson for us to understand. When we need to deploy computers to our environment or update them, do we want to have to get a DVD and walk around to every single computer in our environment and have to run that DVD, do a new install or do an upgrade install, add all the Windows updates, add any specific drivers back in? It's a long process. You might spend 2, 3, 4 hours upgrading a single computer. Not very efficient. What if you're in an environment, the environment example we've been using is an enterprise with 1,000 computers. It would take you, well, at best, if it's 4 hours per computer, that's 4,000 hours of labor to do one upgrade. Very, very inefficient. So we can use Windows deployment services. We can use a pre-built image and deploy that to our computers. This is very helpful. For example, you're not going to use the very latest Windows 10 build. Not all your computers are going to have it. You've got computers that have been purchased over a period of time. You may have some that are in warranty. Perhaps you may even have some that are out of warranty. But you might have Windows 10 computers that have Windows 10 1803, 1809, 1903, 1909. Just because the latest version of Windows comes out, you don't automatically upgrade all your computers to it. You want to prove that it will work in your environment before you deploy that image, before you deploy that upgrade. Well, how do you go about that? Well, we can use WDS, Windows Deployment Services, and we can use it along with the Microsoft Deployment Toolkit. This gives us the ability to be able to work with those images and create images that we want with all the applications that we need right out of the box. If you just simply take a DVD and upgrade a computer, you now have a blank copy of Windows 10. It's got no customization. It doesn't have Office. It doesn't have your security suite. It may not have any special, it's not going to have any special software that you require in your environment. It won't have the drivers that are required for it to function properly. It may have some baseline drivers, but it may not have the full package of drivers that you need. How do we make that happen? Well, what we can do is, first and foremost, we need to understand what an image is. It's a key component that we use to deploy Windows to our servers and to our client computers. It's a single file or other storage device. It contains the complete contents and structure of a disk or other data storage device used with the computer and other computing devices. It's got all the necessary information to install a copy of Windows onto another machine. Many times what we'll do is we'll use what's called a reference computer. And on that reference computer, we'll install any necessary drivers, all the applications that'll be needed. We'll make sure that it's fully updated and patched to the latest patch versions for Windows. We'll install our security suite perhaps. We may install VPN software, whatever it requires for that computer to function in our environment. Any customization, branding. And then what we do is we capture what is commonly referred to as a golden image. It's that pristine copy of what we want a computer to look like. And we're going to store and access that image from a central location. And that gives us the ability to copy it to other computers. Make sure you take your time and do care to ensure that that reference computer is properly installed and configured and that everything functions properly. You want to make sure that you're not creating multiple user accounts, whatever. Keep it clean and ready for any user to use. You don't want to make it specific for any particular user. It needs to be generalized, and that we'll see that switch later on as well. We want to ensure that that computer complies with any policies your organization has established. Make sure it fulfills that overarching cybersecurity model that's been established by the organization. In this way, right out of the box, you know you're within compliance. It's going to save you a lot of time later on. Sometimes computers get corrupted, right? User calls up, this isn't working, I'm getting this problem, that problem. Well, having that image that you can redeploy gives you a quick and efficient way to restore the proper operation of that system. So you're not wasting hours and hours trying to fix it. We'll see how using group policies we can redirect a user's folder to a file server where it's protected. So when we re-image that computer, there may be some user-specific account information that we want to redeploy, but all the user's files are stored somewhere else. So after we re-image it, the user logs on, and immediately the group policies reconnect everything, and everything works. User is happy. That's what we want. When we're working with these images, remember we said that that's a single file, and it's got all those disk complete contents. It's a WIM file, it's an ISO file. There's many different types. But basically what we're going to talk about when we talk about disk images, we're going to have a thin image, a thick image, or a hybrid image. A thick image is an image that has everything. It's got the OS, it's fully patched, it's got all the core applications, it's got any additional language files, it's got all the drivers it needs, it's got Microsoft Office ready to go. It's very large, but it's got many advantages over that thin image. Thin image is basically just the baseline OS. It's got a lot of advantages over that because it's got all those applications. It's ready to use right out of the box. After you deploy a thick image, applications, language pack, it's all immediately available to the end user. Now, a disadvantage to that is it's very large. Creating and testing it requires a lot of work. And you need to keep it updated. Because remember, we're deploying this as a fully updated system. And what happens if we migrate from Office 2013 to Office 2016 to Office 365, and then any other applications that need to be updated? So it's a constant process that you need to be managing those images to rebuild them, retest them, and then redistribute them. So it can be a lot of maintenance. The flip side of that, as we already discussed, was that once it's deployed, it's done. You're done. You wash your hands of it, and the user goes. Now, the other side of that is your users, your computers may get more applications than they require. That's another disadvantage. Thin images, as we kind of talked about, it's the complete opposite. It's the opposite of thick images. It's got operating systems, and it may have software updates. It's got probably no applications pre-installed. It's got no extra language packs. So once you deploy a thin image, you still need to be doing updates. You need to be doing software installations. They're easier to and faster to install. It costs less to maintain and test them. The image size is smaller, so your storage cost is lower, and it's more flexible. But you're going to have a lot more time to do your deployments. You may have to do some special scripting to do it. You're going to have to build a software distribution infrastructure. We may take a look at that using the Microsoft Deployment Toolkit. Getting that system fully deployed is going to take longer because you're going to do the OS, you're going to do applications, you're going to do updates, you're going to do more and more. The other side of that is It's going to generate more traffic over the network. Now, there's also hybrid images, and it's kind of a happy medium in there. It's going to have the OS. It may be patched. It might have Office already installed. It might have some applications installed. Might not have every single thing that a particular user needs, but it's going to have most of it. Still takes some time to do the maintenance. Still takes a little bit longer to install than a thin image. Doesn't take as long as a thick image. It's in the middle there, right? Now, understand that there's two different types of images. Thick, thin, and hybrid is the way we create our images. There's two different types of images that we can work with: a sector-based image or a file-based image. A sector-based image copies each sector to a file. In other words, it takes that image and copies it to the computer. It is system specific. So understand that you might have a build for, let's say, Dell Optiplex 9040s or whatever it might be, and it will work perfect on those Dell computers. However, if you try to deploy that sector-based image to a Lenovo or to an HP, it may not even boot. Things are going to be wrong. It may not work on other computers that run different hardware. Now, a file-based disk image, it captures images based on the files on the disk. Because it's a file-based image, it's hardware independent. That sector-based image, remember, it copies sectors. The file image is based on the files. Because of this, it can be deployed to different hardware. So we've got a single instance and we've got a single copy of a file that can be referenced many times in a file system tree. When a file-based image is applied, it's non-destructive. So the data files still exist after the image is applied. So that could be a virtual hard disk. It could be a WIM file, a Windows imaging format. That's WIM, WIM. We'll be working with those. Now, what file format do we want to select? Well, if we're working with a virtual machine, a VHD is a great way to go. We can basically take one of those and copy it and use it. Now, once we hit Windows 8 and Windows Server 2012, our virtual hard disk, that VHD, got an upgrade. It got an upgrade to what we call VHDX. And that's been published through the Microsoft Open Source Promise Initiative. It broke some barriers. That original VHD was limited to 2 terabytes in size. That VHDX broke that barrier and just shattered. It just shattered it. It can support a format support size of up to 64 terabytes. So much larger. VHDX is much more flexible. Now, is that what we would deploy to a physical system? Well, you can boot from a VHD on a physical system. But if we're going to deploy a single system to a computer, we're probably going to do it WIM-based. And the WIM, the Windows Imaging Format, it was developed by Microsoft. It allows all those folders and files to be stored in a WIM database. It's actually a database. It's got compression. A single WIM file can have multiple images. Remember when we do our Windows Server 2016 installation, it asks us, hey, do you want to do standard, or rather standard core, or standard desktop experience, data center core? There's multiple versions there, all on that one DVD. There was a time when you would have had to have a separate DVD for each one of those. We can have multiple images in that single WIM. It's file-based, so we can use it on different hardware platforms. We can take that one image and deploy it across multiple platforms and disk sizes. We're not limited to a specific size disk. We can do offline servicing. I'm going to show you how to take that base install WIM. We're going to mount it into a folder. We're going to create an extra folder in the image. We'll create a file in it, and then we'll commit those files, those changes to the WIM. So you can customize that WIM. You can do what's called offline servicing. You could add specific drivers that you needed and then reseal it. There's a lot of advantages to that WIM file. You can do a lot with it. Now, how do we deploy it? Well, we deploy it using either a boot WIM, and that gives us our pre-installation environment and our install WIM. And then you could also doing it if you can't start your computer using the PXE boot, the pre-boot execution environment. You can also create what's called a discover image, and it's a disk that you use to boot from. The boot WIM is our Windows PE. That's our Windows pre-installation environment. We can build that using the ADK, the Assessment and Deployment Kit. We'll be looking at that in our lab. Now that discover image that I said we could use if you're not able to use the PXE, you can create it using what's called static discovery or dynamic discovery. Make sure you understand the difference between those. The static discovery, the image connects to a specific deployment server. Dynamic discovery, that image file emulates the PXE boot process and reaches out to find a deployment server. So in one you're specifying, the other you're letting it find it. Now the install image file, that contains the operating system we want to deploy. So you could take the default install WIM, and in fact right here you can see these. Here's a DVD, Windows Server 2016 Data Center, and in the sources directory in that DVD, here are those files. There is the boot WIM, there's your Windows pre-installation environment, and here is your install WIM. This contains all 4 versions of the Windows Server 2016 operating system. We install from the install WIM, but that is just the base installation. What we'll do in our environment is we'll look at how we take a copy of that and we copy it to our server, and then we can customize that. We build what's called a capture image. So we can use a capture image. Remember we use the boot WIM to do the pre-installation environment to boot a computer. When you first put a DVD in a computer and turn it on, and it says press any key, and then you see the little swirly going around, and then it asks you, hey, how you want to format and all these other questions. That's your Windows PE. And once you've defined all those installation options, then the install takes over and all that stuff's written to the computer. Well, once we've built our reference computer and we want to create our golden image that's got all our customization in it, we use what's called a capture image, and it connects to that computer that's got our predefined system on it, and then we use that to capture that golden image. That's what the capture image does. Now, we need to determine how many images do we need. Well, are we using the exact same system everywhere? Are we using the exact same applications? Do we have the same needs? Are the needs of the sales computers the same as the research computers, as the manager's computers, as the administration? You may have to create many different types of images based on the operating system, the hardware platforms. If you've got different hardware, you may want to create two different images that have different drivers pre-ready to go. The features, language packs, different regions you may configure differently. So Plan out how many different images are you going to need to maintain. You're going to need to periodically update those images. You want to make sure that when you're deploying a computer, if you created that image 2 years ago, after you install it, how many Windows updates are you going to have to then install? You're not done. You might have another half an hour, 45 minutes, and whatever, updating that computer. Periodically update those with the patches, the hot fixes, and those new drivers. How do we go about working on these systems? We use the DISM. That's Deployment Image Servicing and Management. DISM. It's a command line tool. So let's take a look at a couple of those commands, because what we can use it to do is to mount a Windows image. We can then what we call service the image. We could update it with drivers. We could do all sorts of things to it. Let's take a look at a couple of those commands. Here we're going back into our Hyper-V machine that I created, and we looked at where the location is of the install WIM and the boot WIM. So what I have done is I've created a folder called WIM files, and what I did was I copied the boot WIM and the install WIM. This is what we're going to use to mount with. Let's go over to PowerShell. The first thing we need to do is determine, hey, what do we want to work with? Remember, we could update this entire package, or we can update specific versions within that. Remember, there's different operating systems in that WIM. Well, let's take a look. Let's type in the DISM, and first off we want to get image info. And we need to say, okay, what do we want to get image info from? So then we define what is the image file and our path to it, and it's located here. And remember, it was install.wim, and we press enter. And there are the 4 images that are available for us to install from this single WIM. 2016 Standard, which is Core, Standard Desktop Experience, Data Center Core, Data Center Desktop Experience. Let's modify the 4th one. We're only going to modify the 4th one. Before we do that, let's take a little bit deeper look at that 4th one. We're going to do the same command, except this time I'm going to type index 4. See the index numbers there, 1, 2, 3, 4. Well, let's get some detailed information about that Data Center Desktop Experience. Here it gives us more information about it. The build, the version, the architecture, when it was created, when it was modified. Now you see that modified date? Well, that's today. Now, that's the day that I'm recording this, because I was already looking at this. Now, let's mount this image. How do we go about mounting an image to be able to modify it? Well, it's that DISM command, and then we're going to type in mount-image. And there again, we got to tell it where to find that image and the path to it. Is that enough? Well, we've defined what we want to mount, but we need to tell it where to mount it. We also need to specify that we want to work on the Data Center Desktop Experience image. Then we need to tell us, now we need to say where we want it mounted. So we type in /mount_dir, and I created a folder on my computer named mount. You got to do that first. You got to create that folder. This is our mount point. We're going to press enter, and oh, it says it doesn't exist. I thought I already created this. Let's take a look. Yeah, there it is. What did I type wrong? Oh, I didn't do a slash. That's what it is. Right here. Where does that slash go? Yep, right there. There it is. It's reading the image and it's going to extract the contents of that index and place it in the mount folder. Should just take just a few more moments. Takes about a minute. What that's going to do is it's going to extract the contents of our data center desktop experience image to that mount folder. And we'll be able to see the folder structure just as if it was installed onto a computer. We're going to create a new folder. We're going to call it temp. And then in that, I'm going to create a new document. And then what we're going to do is we'll commit those changes so that when we would deploy this, it would already exist. There it is. Operation completed successfully. Let's go back over to File Explorer. We're going to go into Mount. There is the structure of that data center desktop experience. We're going to click. We're going to make a new folder. We're going to call it temp. We'll go into temp and let's make a new text document. There's our new text document. And in fact, let's rename it test file. And this is some text. And we'll save that. Also, what we could now, we've made our changes, we added our applications. We're going to close that. And now what we want to do is we want to commit those changes. So we're going to type in DISM and we're going to do unmount image. We got to tell it, hey, where is the image that we want to unmount? So we need to tell it again that mount dir. And then finally we need to say, hey, we want to commit the changes. So we do a slash commit. Let's see if it works. It's running. We should see it in just a moment saving the changes that we made. Should only take a few more moments. Needs to read those changes, needs to make sure everything's good. Just going to wait here. I promise you, it's going to happen. There's many other things that we can do. We can also use a command. There it goes, saving the image. We could use a DISM command, and we could point to where that image is mounted, and we could use a slash add dash driver, and we could inject new drivers into that image as well. So it saved the changes to the image. Now it's unmounting the image and basically sealing it back into that WIM. And we should see it give us a message that it was successful here in just a few more moments. There's a lot of other things that you can do, and we're going to take a look at those there in your textbook in just a second. Just need to wait for this to finish for us. This is a pretty big chapter, so I know it's going to be a long video, but reading it's one thing, seeing it in action's another. There we are, completed successfully. Now, if we were to remount that image and go back into that mount folder, we would see that mounted with that folder that we created with the document in it. That's how that works. Okay. Here are some of those switches. And if you want to know more about it, for example, here it's all on Microsoft's website on the docs.microsoft.com. This is a listing of how to take inventory of an image or a component using DISM. If we want to modify it, here's all the instructions on how you can go about modifying it. And this is the steps This is the steps that we just did. We mounted it, we modified it, we unmounted it. Now, we didn't do the last thing, we didn't apply it to anything, but we unmounted it. So now we have the modified image file. And then there's also modifying drivers. You can add drivers, you can remove drivers. If you've got an old driver that you just updated and replaced, why leave the old driver? You can remove the old drivers. Just search for it and make sure, for example, if you do this search right here, DISM get image index, you may see here's all our Microsoft, but you might want to restrict that. Do a site Microsoft.com. Just like that, site:/Microsoft.com, and this way it restricts your search to only Microsoft. This works, that search like that works on any search engine. So you can see we're only getting information from Microsoft. Very helpful. Make sure you read through here. Understand what many of these commands are. We can also use our PowerShell to work with the DISM commandlets to add packages, add drivers, disable components. Very similar to using our command prompt. What I was doing in PowerShell, I was running PowerShell in the example that you just saw, but I was running commands. I could have done that from an admin command prompt as well. It's just easier just to do it in PowerShell. But there are specific commandlets for DISM as well. And here you can see many of those. And here's how you might do those same things using PowerShell. For example, mounting Windows image, saving it, dismounting it, adding a Windows driver. Now, what about features? We can use DISM to install features. We could do that on our own computer. We could, for example, we want to install the Hearts game. We could take an image that's mounted here and tell it to enable a feature and go ahead and do it. See, you mount an image offline and then you use it to add, update, remove, list Windows features. Now, how does this work? One of the first things we talked about was WDS, Windows Deployment Services. How does this work with WDS? Well, what we do is we create those images and then we copy those images to our WDS server. It's a Windows Server role that's used to deploy Windows over the network, and it can be done with little or no user intervention. The client can PXE boot, and you can perform an installation over a network with no local operating system or local startup device on it. In other words, just the same way as if you were turning the computer on and installing Windows from a DVD, well, you can connect across the network and do the exact same thing. Remember that WDS, it supports deploying both VHDs and WIM files. Now, if it's going to deploy a VHD file, it's going to copy the file to the local hard drive, and then it configures what's called the BCD, the boot configuration data. And it tells it to start the computer off the VHD. You're not actually writing the file structure. You're just deploying a VHD. It's copying a VHD. That's the only thing that it's copying. And then the computer boots from the VHD. When we want to deploy WDS, as we said, it's a server role. So before we can use it, we have to install the role and configure the services. We'll look at that in our lab. We can use it with Active Directory, and to do so, the server, the WDS server, needs to be a member of our Active Directory. We probably would not want to do this on a domain controller, or it says you could, but I wouldn't do that. There needs to be an active DHCP server on the network. There needs to be active DNS on your network. Well, we kind of need those to make our network work anyhow, right? And we're going to be using an NTFS file system partition on the server to store those images. Now, Beginning with Windows Server 2012, we could deploy WDS in a standalone mode, which means it's not dependent on Active Directory. And here again, you still need DHCP, you still need DNS, and you have to store the images on an NTFS file system partition. There's two different role services that are included: the deployment server and the transport server. The deployment server, this is where we provide the image repository. That's where we're going to store our boot images, our install images, any other files that are necessary for doing remote installation. A PXE server for the remote computers to start. And it also gives us the ability to do TFTP, that's Trivial File Transport Protocol, to transfer files over our network. Using that deployment server, we also have tools to create and customize images. Now, the transport server, it's required by the deployment server, but the transport server is a subset of our functionality. But it can also be used for custom solutions. And that also allows us to use multicasting. Moving on, here's the steps we'll be looking at in our lab. Remember, these textbooks, they show you how to do things. They don't just tell you how to do it. And then additionally, we need to do a number of configurations in it. We can deploy from multicast. Make sure you understand the process for doing that. We'll be looking at in our lab of how we add a boot image, how we add our install images. We'll be creating a capture image. We're going to go a little bit beyond on our lab, or in what I may do is I may include a Hyper-V component showing a little bit additional configuration. We're going to be able to generate that image file with WDS. Remember, we talked about creating a capture image. We'll look at how we do that. We'll look at how we can create a discover image. This is what allows us to boot in a non-PXE environment. We're going to install the Windows Assessment and Deployment Kit. Now, there was a time when you installed the ADK that it included the WinPE, the Windows pre-installation environment, as its installation, and you see that listed right here. Well, since the publication of this text, the ADK and the WinPE ADK have been separated. They're two different processes that need to be installed, so we'll be looking at that. And here is the installation of that. Now, what is WinPE? WinPE, it's our core deployment foundation for Windows 10. We're going to be taking a little bit deeper look in this, and because the Windows PE, it's a compact special purpose operating system. It gives us that environment to be able to do operating system setup, maintenance, imaging tasks. It's a very powerful environment. It's a lightweight bootable version of the Windows operating system. Now, normally when we boot Windows PE, we boot to a command prompt, but you can run GUI-based tools in it. It's used for installing Windows, preparing the system for that Windows installation. It can create our partitions and do drive formatting. It can allow us to do troubleshooting. It can allow us to do Windows recovery. We can start with the Windows PE from almost any boot device. We do that when we start the Windows setup from a DVD or from a USB. It can support both 32-bit, 64-bit hardware, and it can install both the 32-bit and 64-bit versions of Windows. PE is a minimal Windows operating system. Now, should automatically stop running and restart after 72 hours of continuous use. It can't be used as a server. There's many things it can't do, but there's many things that it does very well. We have command line tools that we can use to initialize the BCD, to update boot sectors. How can we create a custom WinPE environment? Well, right here. Instead of loading our install WIM, we can mount the boot WIM. And we can do customization to it. We could add various packages to it. Now, we're going to look at how we go about creating that reference computer. Remember, we talked about it. That reference computer, it's a pristine system that's ready to be deployed. It's got everything we want out of the box. We can use the Windows PE to help work on that. Make sure you understand all the steps in here. So we can boot with a Windows PE USB, and then we can use the DISM to copy the Windows partition. So there's many of these tasks that we can do manually using these various switches that you see here. We'll look at creating what's called an unattend file. It's an answer file that tells us how do you want the partitions created. What do you want to label various volumes? Do you want to give them a disk label? Do you want to give them a volume label? Or give them a drive letter? When we use our sysprep command, we'll be able to generalize it and be able to seal the system. You can see here the sysprep, some of those sysprep commands. Now we can streamline our installation by using that answer file that we talked about, the unattend file. We use what's called the SIM, the System Image Manager. We use that to create those unattend answer files. We'll be looking at that. We can tell it what region we're in, what time zone we're in, how do we want the disk partitioned, what are we installing, do we want to pre-configure virtually anything we want to pre-configure, we can do so using the unattend answer file. We'll be making one of those. And here's a view of that System Image Manager. When we run the sysprep command on our pristine system, we're going to run it with these switches. For example, we'll tell it to generalize, which gets rid of any system-specific data like event logs, the computer name, and it strips the SID from it. Remember, the SID has to be unique. When we install one of these images, each time it has to have a unique SID. So that generalize removes that. We then also use the shutdown, because we're going to generalize it, we're going to shut it down, it'll be sealed. For example, sysprep/generalize/OOBE. What's OOBE? Well, OOBE is out of box experience. So what we're doing is we're telling it that the next time it runs, run the out of box experience. Here's the ways that we can go about capturing the reference image using DISM. We don't have to use our capture image from WDS. We can boot using WinPE and then use DISM to capture that. Takes longer. These are manual things, right? We can do this through our WDS and the Microsoft Deployment Toolkit. Here are those capture image commands. We can do an unattended installation using WDS. We can have it automatically create the system, automatically allow a client to connect to our WDS and deploy the new operating system with no intervention. Be very careful how you do this. You don't want already operating systems connecting to your WDS and getting re-imaged. That might not be a good thing. There's a couple of different ways that we can use the Microsoft Deployment Toolkit. We can do what's called light touch or zero touch, LTI and ZTI. Light touch stores images on our MDT deployment share, and it requires a little bit of intervention. Maybe it asks you what you want to name the computer. Zero touch means just what it says. It uses System Center Configuration Manager, and there's no interaction required whatsoever. We're going to look at how we can use the MDT. We can create what's called task sequences, where we could specify a specific installation is going to pull a specific version of Windows and specific applications and install them in specific task sequences, so that we don't have to have a particular pristine image, that golden image, for every single one of our deployments. Now, this would not be zero touch by any means. This would be light touch. So we may be selecting different components. A lot of different ways that we can customize this. When we're going to do the Microsoft Deployment Toolkit, what's the first line? Plan the MDT imaging strategy. It all goes to planning. Plan it, plan it, plan it. Now, the first time you work with MDT, you're not going to have any prior knowledge, so you need to play with this. You need to understand how it works. It takes time to understand these concepts. But once you do have a handle on the process, plan out your imaging strategy. Everything we do goes back to planning. Make sure you've got your prerequisites. Create your deployment shares. There's times when you'll need to update the deployment share. For example, you create the deployment share, you create those task sequences, you grab your reference computer and you transfer the task sequences and such and the boot image to the reference computer. You run your deployment wizard, you install those operating systems, and then you capture the image of the reference computer. You copy that captured image to the management computer. You create your boot image, you create new task sequences to deploy the captured image to target computers, and then you have to update the deployment share. Because once you've made changes to it, how's it supposed to know that you've got new images to deploy, and if you don't, update the deployment share? We'll be looking at installing the Win80K. We're not going to be working with System Center Control Manager, Configuration Manager. Much of what we do will get stored in a SQL Server database. Now, if we want to view the documentation files, we got to have Word. So here's the steps to install MDT. We'll be looking at that, configuring it. Great tools to have, isn't this textbook? Here's all your sequences, creating those sequences. If you work in an environment where you're going to do this, fall back on this textbook. You will love having this at your disposal. We can virtualize Windows servers. So understand how we can do that. We use our virtual machines. Why do we do this? We do it because of efficiency. It saves computing resources. It saves physical hardware. It saves on power supplies. It saves on cooling. It saves and saves and saves. Make sure you fully read through all the considerations there. Determining considerations for deploying workloads into virtualized environments. What are we talking about? We first need to start with how many virtual computers you need to run. We need to determine that, right? Well, if I need to run 20 virtualized computers, I need to understand how much memory is going to be required. What type of processing requirements are those servers going to use? What kind of storage requirements are those servers going to have? This is determining those workloads, those considerations. Make sure you understand the process for doing that. We can also use the Microsoft Assessment and Planning Toolkit. You can install it on any system running Windows Vista and higher. We may take a look at this, we may not. It just depends on what's required. Time is also a factor. We've only got so much time to address our lessons, right? So what does it do? It performs an inventory of your IT infrastructure and gives you detailed reports about. It can inventory Linux, it can, Unix, VMware. It can give you a lot of metrics about your systems. So here's the processes to install that and then to run it. It can examine your desktop, your systems, look at your desktop virtualization, your server virtualization, can give you an idea of what you can do, where you're at. You can perform your inventories, tell it what do you want in inventory. Specific inventory scenarios. You can collect performance data on your machines. It's a powerful tool, and it's free. You can do what's called the server consolidation wizard. You can have it take a look at your physical infrastructure and see what you can do is from the virtualization side. Lets you see recommendations. We can also plan for Linux and FreeBSD deployments. These are operating systems that we can deploy just the same way as anything else. But we still need to specify how much memory are we going to need? How many of those virtual processors are going to be required? Do we have the resources to do it? You have to plan. But Hyper-V does support these environments. So this was a lot in this lesson. The lab is going to be long. I may even make a second video for hands-on activities. But we talked about how an image, it's a single file, and it contains the contents and structures of a disk or other data storage device that's used with computers and computing devices. It's got all the information that needs to be installed as a copy of Windows onto another machine. Most of the times we're going to create an image from a reference or master computer. We're going to create what we call a golden image. On that reference machine, we're going to fully patch it. We're going to have Windows updated. We're going to have any applications that are required. You're going to make sure that it's ready to go. It's the largest format of our images, but it's also the one that allows a user to get it and go as soon as possible. We can use a WIM, the Windows Imaging Format, and it's that file-based image that allows us to deploy to different hardware. We can use DISM, and we took a look at an example of that, of how we can use DISM to manage our images and maintain those images. We talked about Windows Deployment Services and how it's a Windows Server role that allows us to deploy Windows over the network. So we can deploy many copies of Windows at the same time. If our client computers can PXE boot, which most all of them can, you can do an installation over the network. We can also use that Discover image to be able to connect to our WDS if that system is unable to do the PXE boot. We briefly discussed how data centers consolidate many physical servers into a single server running virtual machines or virtual servers. It creates significant cost savings. It allows us to drastically increase our use of our resources while reducing the overall cost and power consumption. Physical servers are typically very underused. Typical physical server will run with 5 to 10% utilization of its resources. It's very inefficient. That's why virtualization is so efficient. Then we finally took a brief look at the MAP toolkit, the Microsoft Assessment and Planning. And it's a great tool to allow you to inventory, assess, and report on an organization's environment. So even if you're not going to use it to plan for a move to virtualization, you can use it for inventory asset management. I hope you enjoyed 70-740 Lesson 6, and we'll be picking this up in your lab. Thank you.